People look at the moon almost every night, yet rarely question it. It hangs above cities, fields, oceans, and deserts with the same calm presence it has always had. Familiar, predictable, silent. So familiar, in fact, that most people never think to ask why it is there at all. From childhood, we are taught that the moon is natural, a companion to Earth, a simple part of the sky, something that has always existed, always watched, always followed the same path without interruption. The explanation feels complete, so curiosity quietly fades. But familiarity has a way of hiding strangeness. The moon is not small. It is unusually large when compared to the planet it orbits. In fact, no other rocky planet in our solar system has a moon so massive in relation to itself. If Earth were only slightly smaller, the moon would not orbit it at all. The balance is precise. Almost too precise. It does not drift randomly. It does not wobble wildly. It moves in a stable, nearly perfect rhythm, holding its position with quiet consistency. Day after day, year after year, as if it were placed exactly where it needed to be. Most people never question this. They accept it the same way they accept gravity or time. But some find the arrangement unsettling. Not because it is mysterious, but because it is convenient. Too orderly. Too cooperative. The moon controls tides. It influences cycles. It shapes calendars, seasons, and biological rhythms. Human sleep, animal behavior, and even ancient agriculture have long been tied to its presence. Remove the moon, and Earth becomes a very different place. Yet despite its importance, the moon remains distant, untouched, quiet, always showing the same face, as if deliberately hiding the other side from view. Ancient cultures noticed this long before modern science existed. They wrote stories about the moon arriving suddenly, or being different from the rest of the sky. Some myths speak of a time before the moon, a darker sky, a quieter night. Modern science offers explanations, models, and theories. But explanations do not always dissolve doubt. Sometimes they sharpen it. Because once the question forms, it does not easily disappear. What if the moon is not just a natural satellite? What if it is not simply a leftover fragment of cosmic chaos? What if its silence is intentional? The moon does not speak. It does not signal. It does not reveal. It simply remains, perfectly positioned, perfectly timed, and endlessly observed. And once that thought settles in, it becomes difficult to look at the night sky the same way again. Because the moon may be familiar. But familiarity does not always mean understanding. Once the idea takes hold, it becomes difficult to ignore the details. The moon begins to feel less like a background object and more like something that demands a closer look. In space, size matters. Distance matters. Balance matters. And when scientists compare the moon to Earth, the relationship appears unusual. The moon is not a small companion. It is massive, nearly 1/4 the size of Earth itself. In proportion, it is far larger than any other moon relative to its planet in the solar system. This alone would not be strange if it were common. But it is not. Mars has 2 moons, both tiny and irregular. Jupiter and Saturn have many moons, but their size is insignificant compared to the planets they orbit. None of them come close to the Earth-Moon ratio. The pairing stands alone. The distance is just as precise. The moon is far enough away to avoid breaking apart under Earth's gravity, yet close enough to exert powerful influence. It does not spiral inward. It does not drift outward uncontrollably. It remains locked in a stable orbit that scientists describe as remarkably orderly. Order, however, is not the same as simplicity. If the moon were slightly closer, tides would become extreme. Coastlines would change dramatically. If it were farther away, tides would weaken and life on Earth would have evolved very differently. The margin is narrow. The placement feels exact. Some scientists describe this balance as coincidence. Others call it rare, but natural. But outside scientific language, the precision leaves an impression that is hard to dismiss. The system works too well. The moon does more than orbit. It stabilizes Earth's tilt. Without it, the planet would wobble unpredictably, causing extreme climate shifts. Seasons would become chaotic. Long-term life might never have developed in a stable form. In other words, the moon does not merely accompany Earth. It protects it. This role is rarely emphasized. The moon is often treated as passive, but in reality, it acts like an anchor, quietly maintaining balance while remaining distant and silent. That silence is important. The moon does not behave like debris captured by chance. Its motion is smooth. Its position is cooperative. Its influence is constant. Some researchers have described the Earth-Moon system as finely tuned. Not fragile, but deliberate in its stability. A system that works because everything is exactly where it is. For most people, this precision inspires no concern. But for others, it raises a quiet question. Natural systems are often messy, asymmetrical, imperfect. The moon is none of these. It is large. It is stable. It is perfectly placed. And the more closely it is examined, the harder it becomes to accept that it is simply there by accident. Not because it is mysterious, but because it behaves as if it belongs exactly where it is. As if it was never meant to be anywhere else. The precision becomes even more noticeable when the moon passes directly in front of the sun. For a brief moment, day turns into night. The sky darkens. Temperature drops. Birds fall silent. And in that narrow shadow, something remarkable happens. The moon and the sun align so perfectly that one completely covers the other. From Earth, they appear almost exactly the same size. This should not be possible so often. The sun is enormous, more than 400 times larger than the moon. And yet, it is also about 400 times farther away. The result is a near-perfect overlap, precise enough to create total eclipses that last just long enough to feel deliberate. In most natural systems, proportions do not line up so neatly. Distances vary. Sizes mismatch. Outcomes are approximate. But here, the geometry works with almost unsettling accuracy. If the moon were slightly smaller, it would never fully cover the sun. If it were slightly larger, eclipses would be crude and brief. If its orbit were different by even a small margin, the effect would vanish entirely. Yet the alignment holds. Ancient civilizations noticed this long before modern measurements existed. They tracked eclipses with careful attention, building monuments and calendars around them. To those cultures, the event felt meaningful, not random. The sky appeared to pause, as if something greater was briefly revealed. Even today, eclipses feel different from other celestial events. They are not subtle. They demand attention. People travel across continents to stand in the moon's shadow for a few minutes of darkness. Some scientists explain this as coincidence layered on coincidence. A rare outcome of complex formation. Statistically unlikely, but not impossible. Others acknowledge the rarity while stopping short of speculation. Outside scientific circles, the alignment invites a different reaction. The question is not how it happens, but why it happens so well. Why does the moon's size and distance produce such a precise visual effect from only one place in the solar system? Why does it work only from Earth and nowhere else? Some suggest this is the result of chance observed by conscious beings who happen to exist at the right time. Others find that explanation unsatisfying. The odds feel narrow. The timing feels exact. When seen repeatedly, perfection begins to feel intentional. The eclipse does not prove anything on its own, but it adds weight. Another detail that fits too cleanly. Another moment where the moon behaves less like a random fragment and more like a carefully positioned object. It does not glow. It does not signal. It simply aligns, blocks, and moves on, leaving questions behind in its shadow. And once those questions appear, they tend to spread. Because eclipses are not the only time the moon behaves in ways that feel strangely mechanical. There are moments when the moon does more than pass silently through space. Moments when it responds. The moments that followed were unexpected, even to the scientists who designed the experiments. During the Apollo missions, instruments were placed on the moon to study its internal structure. These seismometers were meant to record moonquakes and impacts, nothing more. The goal was simple: understand what the moon is made of and how it behaves beneath the surface. Then something unusual happened. When spent rocket stages were deliberately crashed into the lunar surface, the moon responded in a way no one had anticipated. Instead of absorbing the impact and settling quickly, the vibrations continued, and continued, and continued. Scientists described the phenomenon with a phrase that would later take on a life of its own. They said the moon rang like a bell. The vibrations lasted far longer than expected, sometimes for hours. The moon did not dampen the energy the way Earth does. It behaved as if it were rigid, dry, and strangely resonant. At the time, this was not framed as a mystery. Engineers explained it through material properties. The moon lacks water. Its interior does not absorb shock efficiently. Without moisture to dampen vibrations, seismic waves can travel farther and last longer. The explanation was reasonable. It was recorded. The data was archived. But outside scientific circles, the phrase lingered. A bell rings when it is hollow. A structure resonates when it has space within it. The idea spread quietly at first. People began to ask questions not about the data, but about the interpretation. Why did the moon behave more like a rigid shell than a solid mass? Why did impacts echo instead of fading? As more data was analyzed, scientists mapped the moon's interior. They found layers, a crust, a mantle, a small core. But they also found vast variations in density, regions where material behaved differently than expected. To most researchers, these findings fit within natural models. The moon formed violently. It cooled unevenly. Its interior was never meant to mirror Earth's. But to others, the data felt incomplete. The moon's density is lower than Earth's. Not drastically, but noticeably. When compared side by side, Earth feels compact and heavy. The moon feels lighter than it should be for its size. Again, science offers explanations. Composition, formation, history. Still, the questions remain, not because the answers are absent, but because they do not silence doubt. If the moon were completely solid, its response would be different. If it were layered differently, the vibrations would behave another way. Yet what was observed sits in a narrow space between expectation and anomaly. The moon does not shatter. It does not absorb. It resonates. It responds. And for some, that response feels less like geology and more like structure. Not proof. Not confirmation. Just another quiet detail that refuses to settle comfortably. Because natural objects are expected to behave unpredictably, the moon behaves consistently. And consistency, when observed long enough, invites interpretation, especially when the object in question has been watching silently for billions of years. The idea grows slowly from there, not as a conclusion, but as a possibility people return to again and again. If the moon can resonate, some begin to wonder what lies beneath the surface. Not small cavities or fractures, but something larger, something structural. This is where the hollow moon idea quietly enters the conversation. On Earth, density is a familiar concept. Heavy objects sink. Solid bodies feel weighty. When scientists calculate the moon's average density, the number comes back lower than expected. Not dramatically low, but noticeably different. Lower than Earth. Lower than many assume a body of its size should be. To geologists, this is explanations. Different composition. Different formation history. The moon contains less iron. Its core is small. Its mantle is dry. These facts account for much of the difference. But outside geology, numbers can take on another meaning. A hollow object is lighter than a solid one. A shell weighs less than a filled body. When people hear low density, the image that forms is simple and immediate. Space inside. The idea does not require complete emptiness. It allows for chambers, voids, regions that are not fully solid, areas that serve no obvious geological purpose. Some point to lunar craters that appear shallow compared to their width. On Earth, impacts dig deep scars. On the moon, many craters seem to stop abruptly, as if they reached a harder layer beneath the surface. Others point to mascons, massive concentrations of gravity beneath certain lunar regions. These dense pockets contrast sharply with surrounding areas, creating a patchwork that feels uneven. To scientists, mascons are remnants of ancient impacts and lava flows. To others, they feel placed. The hollow moon idea does not claim the moon is empty. It suggests structure, reinforcement, design layered beneath a surface meant to appear natural. It is a subtle distinction, but an important one. A completely hollow moon would collapse. A structured moon could remain stable indefinitely, strong, balanced, quiet. This is where imagination begins to blend with observation. Data points become anchors for speculation. Each anomaly supports the next question. Why would a natural satellite form this way? Why would its interior behave so differently from expectation? Why does it feel less like debris and more like architecture? Science answers these questions with models and equations. Those answers are valid. They explain much, but they do not always satisfy. Because there is another layer to curiosity that does not respond to numbers. The moon does not feel chaotic. It feels controlled. Its surface bears scars, but its behavior remains steady. It does not crack apart. It does not change unpredictably. It holds its shape. It holds its position. It holds its silence. And once the idea of internal structure forms, it becomes difficult to unsee. Not as belief, not as certainty, but as a quiet question that lingers each time the moon rises, smooth and unchanged, above a world that rarely stops to wonder what might be hidden inside. The question moved beyond curiosity in the early 1970s, when it appeared not in fiction, but in an unexpected place. In the Soviet Union, two researchers, Mikhail Vasin and Alexander Sherbakov, published a paper that asked a question few scientists were willing to say out loud. They did not claim certainty. They did not offer proof. They simply proposed a possibility. What if the moon was not natural at all? Their idea became known as the spaceship moon theory. According to this hypothesis, the moon could be an artificial construct, created somewhere else and later positioned into Earth's orbit by an advanced intelligence. The suggestion was not that the moon was built recently, or even within human history. The theory placed its origin far deeper in time, possibly billions of years ago, when the solar system itself was still forming. Vassin and Sherbakov pointed to the same anomalies others had noticed. The moon's low density, its unusual internal response to impacts, its stable orbit, its ability to influence Earth in ways that seem almost protective. They proposed that the moon might be a hollowed body, reinforced from within, designed to endure immense stress. Its surface could be layered to absorb impacts. Its interior could contain massive structural supports. Over time, natural debris and dust would give it the appearance of a normal celestial object. In their view, the moon was not a spacecraft in motion. It was a parked object, a megastructure, silent and inactive, positioned with precision. The idea did not spread loudly. It was not promoted as fact. It appeared quietly in academic discussion, then faded into the background. But it never disappeared. Decades later, the theory resurfaced in fringe science and UFO research. Writers and theorists expanded on it, imagining vast internal chambers, artificial gravity control, or observation systems buried deep beneath the lunar crust. The theory's strength was never evidence. It was coherence. It tied together many unrelated questions into a single explanation. Why the moon is so large. Why it is so stable. Why it behaves differently from expectation. Why it seems to serve Earth rather than simply orbit it. Science, of course, offers alternative explanations. Natural formation models account for the moon's composition and structure. Engineers dismiss the idea of an ancient megastructure as implausible. But dismissal does not erase fascination. The idea of an artificial moon touches something deeper than logic. It suggests intention on a scale almost impossible to imagine. A project spanning epochs. A presence that shaped the environment of Earth long before humanity existed. Whether the theory is plausible or not is almost secondary. What matters is that it reframes the moon, no longer as a passive object drifting through space, but as something placed, something waiting, something that may not belong entirely to the natural order of the sky. And once that idea enters the mind, the moon no longer feels like a coincidence. It feels like a decision. And decisions imply purpose, which leads naturally to another question. If the moon was placed here, then where did it come from? And why does it remain exactly where it is? If the moon was not formed alongside Earth, then its presence raises a different kind of question, not about composition, but about arrival. In most cases, objects in space do not simply settle into place. They collide. They drift. They break apart. Gravity pulls them inward or flings them away. Stable orbits usually emerge after long periods of chaos. The moon's orbit, however, appears unusually calm. It does not spiral closer to Earth in any dramatic way. It does not wobble unpredictably. Its path is smooth, measured, and persistent. For something so massive, this stability feels earned rather than accidental. Some have suggested that the moon was once a wandering object, captured by Earth's gravity, a foreign body pulled in from elsewhere. But capture is a violent process. It leaves scars, heat, instability. The moon shows no clear signs of such trauma. Instead, it behaves as if it belongs. This has led to speculation that the moon was guided into place. Not thrown, not caught, but positioned, adjusted until balance was achieved. To scientists, orbital mechanics explain much of this behavior. Tidal forces, gravitational interactions, and long-term evolution smooth out irregularities over time. These explanations are solid. They describe how orbits can stabilize naturally, yet the quiet precision still unsettles some observers. The moon's orbit is not only stable, it is cooperative. It maintains a distance that allows tides without destruction. It stabilizes Earth's tilt without overwhelming it. It supports long-term environmental consistency. This relationship feels less like coincidence and more like alignment. If the moon were closer, Earth's oceans would surge violently. If it were farther away, tides would weaken and climate patterns would shift. Life as we know it might never have formed. The margin is narrow. The idea that the moon arrived and settled into this exact position, without adjustment, stretches probability in the minds of some theorists. They imagine fine-tuning, gradual correction, intentional placement. In this view, the moon is not a relic of chaos. It is a tool of balance. Again, this does not prove design. It suggests suitability. The moon works. It performs its role flawlessly, without intervention, without change. That performance has continued for billions of years. Objects formed by chance often degrade. Orbits decay. Systems shift. The Earth-Moon system has remained remarkably consistent. The moon recedes slowly, yes, but predictably, safely, without threat. This steadiness adds to the growing list of traits that feel less like accident and more like arrangement. If something were meant to observe Earth over long periods of time, it would need stability, a platform that does not drift, a vantage point that does not change. The moon offers exactly that. High above the planet, locked in rhythm, always present. Whether natural or artificial, it behaves like something designed to stay. And once the moon is seen as something that arrived rather than formed, the question shifts again, not to how it works, but to why ancient cultures noticed it so deeply, and why some of them remembered a time when it was not there at all. Ancient cultures watched the sky with patience that modern life rarely allows. They did not have telescopes or instruments, but they had memory. They tracked patterns across generations, noticing what changed and what did not. In some of the oldest myths, the moon does not feel eternal. Stories from different parts of the world speak of a time before the moon was part of the sky. In Greek tradition, the Arcadians were called proselenes, meaning before the moon. Their legends suggested an age when nights were darker and the heavens looked different. Similar ideas appear in ancient African, Australian, and South American traditions, where early stories describe a sky that was quieter, less structured. These accounts are not scientific records. They are myths. But myths often preserve observation in symbolic form. They carry memory rather than measurement. To historians, these stories reflect cultural change, metaphor, and the human tendency to explain the unknown. To others, they hint at something more literal. The suggestion that the moon arrived at some point in humanity's distant past, not as a gradual formation, but as an event. The moon's sudden importance in ancient calendars adds to this curiosity. Many early civilizations built their understanding of time around lunar cycles. Months, rituals, planting seasons, and religious observances were tied to its phases. The moon became central quickly, as if it demanded attention. If the moon had always been there, this focus would feel natural. But in stories where it appears as a newcomer, the emphasis feels reactive, as if people were adjusting to something new in the sky. Some myths describe the moon as a gift. Others describe it as a watcher. A few describe it as an object that changed the world when it arrived, altering tides, light, and behavior. The moon's influence on human psychology is well documented. Its light affects sleep. Its cycles influence mood and perception. In ancient times, without artificial light, the moon would have felt powerful, even intrusive. To skeptics, this explains the myths entirely. A bright object in a dark sky naturally becomes symbolic. Fear and awe-shaped stories. But symbolism does not erase coincidence. Why do so many cultures independently describe the moon as different from the rest of the sky? Why is it often separated from stars and planets in mythology, treated as something distinct, almost foreign? The moon does not move like the stars. It does not wander like the planets. It follows its own path, bright, close, and dominant. Whether these myths record an event or simply reflect human imagination, they reinforce the same pattern. The moon is not just another object. It is other. Ancient people may not have spoken of spacecraft or megastructures, but they noticed difference. They noticed presence. And presence, once noticed, has a way of shaping belief. As these stories passed through generations, the moon became more than light in the sky. It became a symbol of change, of cycles, of something that arrived and stayed, which leads naturally to another layer of meaning. Because beyond myth and memory, the moon did not just mark time. It began to define it. As the moon settled into human awareness, it began to take on a role far beyond illumination. It became a measure. Long before clocks or written calendars, people looked to the moon to understand time. Its phases divided nights into patterns that could be counted, remembered, and predicted. The waxing and waning became a rhythm that guided planting, harvesting, travel, and ritual. Time itself began to move with the moon. Unlike the sun, which marked days, the moon shaped months. Its cycle created repetition, a sense of return, something that disappeared and came back again, reliably, without instruction. This reliability gave the moon authority. In many cultures, it became associated with order. Kings ruled by lunar calendars. Ceremonies aligned with full moons. Religious observances depended on its phases. The moon was no longer passive. It was consulted. Symbols followed naturally. The moon became linked to fertility, rebirth, and transformation. Its changing face suggested cycles of life and death, growth and decay, disappearance and return. At the same time, it carried a darker meaning. The moon governs the night, a time when certainty fades. Shadows stretch. Sounds change. Fear becomes easier to imagine. In this space, the moon was not only a guide, but a witness. Stories emerged describing the moon as an eye in the sky, watching silently as events unfolded below, always present, always returning to the same position. This idea appears again and again. In folklore, the moon observes lovers, travelers, and crimes. It sees what the sun does not. It knows what happens in darkness. Psychologically, this makes sense. The moon is bright enough to reveal shapes, but not details. It illuminates without clarity. The mind fills in what cannot be seen. Over time, this combination of guidance and uncertainty gave the moon a dual nature. It was trusted and feared, celebrated and avoided, a symbol of balance and instability at once. If the moon were simply a rock, these layers of meaning would feel excessive. But its influence is constant. its presence unavoidable. It is the largest object in the night sky, commanding attention whether one seeks it or not. Some theorists suggest this symbolic power is no accident. If an advanced intelligence wanted to influence a developing species, it would not need to interfere directly. It could shape environment and perception instead. A constant presence, a reliable rhythm, a silent observer. The moon fits all three. This does not require intention to function. The effect would be the same whether the moon was placed deliberately or formed by chance. Human psychology responds regardless. But the alignment is difficult to ignore. The moon controls tides. It marks time. It shapes myth. It influences sleep and emotion. Few objects exert such wide influence without ever changing their behavior. As the moon's symbolic role deepened, so did curiosity about its surface. If it shaped life so profoundly, perhaps it held more than light and shadow. Perhaps it held signs. And as technology advanced, humans finally gained the ability to look closer than ever before, turning lenses and cameras toward the moon, searching not for myth, but for detail. What they believed they saw would open an entirely new chapter of speculation. By the time humans developed telescopes powerful enough to study the moon closely, its role began to shift again. It was no longer just a symbol. It became an object of scrutiny. Early astronomers expected to find a dead, scarred world. A simple celestial body shaped by impacts and erosion. But as magnification increased, so did unease. The moon did not behave like other natural objects in the sky. Its surface was strange. Craters appeared unnaturally circular, with sharply defined edges. Some had central peaks, as if something beneath had pushed upward after impact. Others seemed too shallow for their size, as though the surface concealed something harder below. Even more puzzling was the moon's uniformity. Where planets show variation, mountains, erosion, layering, the moon appeared oddly consistent. Vast flat plains, later called Maria, spread across its surface like frozen seas. Yet there was no water, no atmosphere, no clear explanation for how such smooth expanses formed. Then there was the matter of density. As scientists calculated the moon's mass, they found it was lighter than expected. Much lighter. For its size, the moon should have been denser, more compact. Instead, it behaved as if it were partially hollow. This idea was not popular. A hollow moon challenged everything known about planetary formation. Natural satellites form from debris, gravity pulling matter inward, compressing it over time. Hollowness suggested the opposite. Empty space, structure, design. The theory was quietly shelved, but questions remained. When space agencies began planning lunar missions, new data complicated the picture. Seismic instruments placed on the moon during Apollo missions recorded vibrations unlike anything seen on Earth. When lunar modules impacted the surface, the moon rang. Not metaphorically. It vibrated like a bell. For nearly an hour. A solid rock should absorb energy quickly. Vibrations should fade. But the moon carried them, echoing through its interior as if it were rigid, or layered, or reinforced. NASA scientists described the moon as ringing like a bell, a phrase that would echo far beyond technical reports. Public explanations focused on dry rock and lack of water. But privately, some researchers admitted the data was difficult to reconcile with standard models. Then there were the anomalies. Magnetic regions where none should exist. Localized gravity pockets that affected spacecraft trajectories. Areas where instruments behaved unpredictably. Each anomaly could be explained individually. Together, they formed a pattern of discomfort. The moon was not behaving like a passive, natural body. It reacted. It resonated. It possessed internal complexity far beyond expectations. And still, it remained silent. No atmosphere. No erosion. No tectonic activity. A world frozen in time. If something had been placed there, constructed, not formed, it would explain much. Uniformity, density discrepancies, structural resonance. The idea was unthinkable to mainstream science. But once the question was asked, it refused to disappear. What if the moon was not hollow by accident? What if it was built to last? As humans prepared to walk on its surface, they believed they were stepping onto a dead world, a relic of cosmic violence. They did not yet consider the possibility that they were approaching something engineered, something ancient, something watching quietly, exactly where it had always been. As preparations for lunar landings accelerated, attention turned from telescopes to trajectories. Getting to the moon was not as simple as pointing a rocket and firing it into space. The path mattered. Timing mattered. Angles mattered. And this is where another quiet strangeness emerged. The moon's orbit is unusually precise. It does not wander the way many natural satellites do. It follows a near-perfect circular path, stabilized in a way that minimizes chaos. Even more curious, the moon is tidally locked to Earth. It always shows the same face, never turning, never revealing the other side without deliberate effort. To ancient observers, this was invisible. To modern physicists, it was unsettling. Tidal locking can occur naturally, but the odds are low, especially with such precision. The moon's size relative to Earth is also unusual. It is far larger, proportionally, than most moons compared to their planets. Almost too large. Almost as if it were placed to dominate the sky. And then there is the distance. The moon sits at exactly the right range to perfectly cover the sun during total eclipses. Not slightly larger. Not slightly smaller. Exact. Close enough to block the sun's disk with eerie precision, revealing the corona like a glowing crown. This balance is temporary in cosmic terms. The moon is slowly drifting away, which means that we exist in a narrow window of time where perfect eclipses are possible at all. A coincidence, perhaps, or a calibration. When early spaceflight engineers calculated gravitational interactions, they noticed something else. The moon acts as a stabilizer. It dampens Earth's axial wobble, preventing extreme climate swings. Without it, Earth's tilt would vary wildly, destabilizing seasons, oceans, and ecosystems. Life, as we know it, might not exist without the moon. It is not just nearby. It is necessary. The more scientists studied orbital mechanics, the more the moon appeared less like a random byproduct of formation and more like a system component. Integrated, functional, purposeful. Yet official language remained cautious. Unusual, rare, statistically improbable, never intentional. Still, doubts crept in. The moon does not rotate independently. It does not tumble. It behaves like a fixed platform, a constant presence, exerting quiet control over tides, time, and biological rhythms. Even human sleep cycles respond to lunar phases, as if something ancient, older than memory, is still influencing us. If one were to design a stabilizing body for a young, fragile planet, it would look remarkably like the moon. Perfect mass, perfect distance, perfect behavior, not too close, not too far, never changing its face, always there, By the time rockets stood on launch pads, humanity believed it was about to conquer the moon. But another possibility lingered beneath the calculations: that the moon was not simply an object to reach. It was a system to approach. And systems are rarely accidental. Long before astronauts ever set foot on its surface, the moon had already been speaking to us in another way. Through sound. When Apollo missions finally reached the moon, one of the earliest surprises came not from what the astronauts saw, but from how the moon behaved when it was struck. During seismic experiments, astronauts deliberately crashed spent rocket stages into the lunar surface to study its internal structure. What followed was unexpected. The moon rang. Not metaphorically, not poetically, literally. Seismometers recorded vibrations that lasted far longer than anticipated. Instead of dull, quickly fading tremors like those produced on Earth, the moon reverberated for minutes, sometimes nearly an hour. Scientists described it with a phrase that would quietly echo through internal reports. The moon rang like a bell. A solid rock should absorb shock. A layered body should dampen vibrations. But the moon responded as if it were hollow, or at least structured in a way that allowed energy to travel freely, bouncing within. Public explanations pointed to dryness, lack of water, rigid rock. Yet those explanations never fully satisfied the data, because the vibrations were not chaotic. They were uniform, predictable, contained, as if the energy was moving through chambers. Around the same time, another anomaly resurfaced from earlier missions. Lunar density measurements suggested that the moon's mass distribution was uneven. Certain regions were far denser than expected. These areas, called mascons, mass concentrations, caused gravitational anomalies strong enough to affect spacecraft orbits. Satellites passing over them were pulled slightly off course, requiring constant correction. Mascons were not evenly spread. They appeared deliberately placed. Like anchors. Natural explanations again followed. Ancient impacts, lava flows, crustal thickening. But the pattern remained strange. If the moon formed from debris, its interior should be relatively uniform. Instead, it behaved like a reinforced structure, heavy where stability mattered, lighter where resonance could occur. Engineers noticed something else. The moon's crust is incredibly hard, harder than Earth's mantle rock. Impact craters suggest a surface capable of withstanding tremendous force without collapsing inward, almost like armor. If the moon were hollow, or partially hollow, it would need structural reinforcement to maintain integrity. Dense nodes, thick outer shell, internal support. The data did not prove this, but it whispered it. Even more unsettling was how quickly these findings faded from public conversation. Apollo summaries emphasized success, heroism, and exploration. The ringing moon became a footnote. Mascons became technical jargon. Yet among engineers and physicists, the questions lingered. Why does a natural satellite behave like a resonant body? Why does it contain gravitational stabilizers? Why does it respond more like a construct than a fragment? When you strike a bell, it rings because it is shaped to ring. The moon rang because it could. And the longer it echoed through the vacuum, the harder it became to ignore a growing thought. That perhaps the moon was not just reflecting sunlight. It was reflecting design. Long before modern science tried to explain the moon with equations and models, ancient cultures were already uneasy about it. Not because it was distant, but because, in their oldest stories, it was new. Across civilizations that never contacted one another, the moon is described not as eternal, but as something that arrived. In ancient Greek texts, Aristotle recorded legends from Arcadia claiming there was a time before the moon. The people of Arcadia were called proselenes, literally, those who lived before the moon existed. They did not speak of a forgotten era. They spoke of memory. In Bolivia, legends from the Inca describe a time when the sky changed suddenly, when a great light appeared and nights were no longer dark. The moon, they said, rose one night and never left. In Africa, the Zulu tell of two brothers who stole the moon and placed it in the sky, hollow and filled with fire. The story does not describe creation. It describes placement. Chinese records from the Zhou dynasty speak of the moon as an artificial object, inhabited by beings who maintained it. Early Taoist writings describe the moon as crafted rather than born. Even Aboriginal Australian lore speaks of a sky object that arrived and altered tides, seasons, and life itself. Different languages, different continents. Same idea. Arrival. Modern scholars often dismiss these accounts as metaphor, symbolism, myth. But myths usually distort reality. They do not invent the same distortion globally. What ancient observers noticed was not orbital mechanics or gravitational equations. They noticed change. Tides behaving differently. Night cycles altered. Biological rhythms shifting. The moon governs Earth's tides with remarkable precision. It stabilizes Earth's axial tilt, preventing extreme climate swings. It slows Earth's rotation, lengthening days. Without the moon, complex life might not exist as it does. That alone is strange, because the moon is far too large relative to its planet. No other terrestrial planet has a satellite so massive in proportion. It is also positioned at exactly the distance where it perfectly eclipses the sun from Earth's surface. A cosmic coincidence so precise it borders on absurd. Ancient people did not calculate these ratios, but they felt the effect. They saw a sky object that controlled water, fertility, time, and cycles, and they did something telling. They worshipped it, but cautiously. Unlike the sun, which was praised openly, the moon was often associated with watchers, judges, and hidden knowledge. Lunar deities were not warm. They were observant. Eyes in the sky. If the moon were placed intentionally, its position would need to be exact, its mass carefully balanced, its influence subtle but absolute. Not too close, not too far, not too heavy, not too light. A natural accident rarely lands perfectly. A designed object must. The ancients did not call it a spaceship. They lacked the word. But they described something that appeared, changed the world, watched silently, and never left. And as modern science peeled back layers of lunar mystery, it began, quietly, to echo what the ancients had already implied. The moon behaves less like a relic of chaos, and more like an instrument that was switched on. As these ideas accumulated, a quiet tension formed between speculation and science. Modern astronomy does not ignore the moon's strangeness. It studies it carefully. Over decades, researchers have built models that explain much of what we observe, without invoking intention or design. The most widely accepted explanation for the moon's origin is known as the giant impact hypothesis. According to this model, a Mars-sized body collided with the early Earth billions of years ago. The debris from that impact was thrown into orbit, where it gradually coalesced into the moon. This theory explains many things. Why the moon lacks volatile elements. Why its composition is similar to Earth's mantle. Why it has a relatively small core. From a scientific perspective, the moon is not mysterious. It is rare, but not impossible. Unusual, but not artificial. Yet even within this model, questions remain. Simulations of the giant impact often struggle to reproduce the moon exactly as we see it today. Small changes in impact angle or speed can produce vastly different results. Many versions of the model require fine-tuning to arrive at a moon with the right mass, orbit, and behavior. Science acknowledges this. The theory is refined constantly. New data leads to new adjustments. But refinement itself reveals something important. The moon is difficult to recreate. Its size, its orbit, its internal structure, its long-term stability. Each can be explained individually. Together, they form a puzzle that resists simple answers. This is where speculation steps in, not to replace science, but to sit beside it. Speculation asks different questions. Not how the moon formed, but why it works so well. Not whether it could be natural, but whether natural explanations fully satisfy human intuition. Science relies on probability. If something can happen, then given enough time, it will. Speculation focuses on alignment. When many rare conditions coincide, the result feels meaningful. Neither approach is wrong. They simply speak to different parts of the mind. Science seeks closure. Speculation seeks wonder. The danger comes when the two are confused. When theories become beliefs. When questions harden into certainty. That is not where this story lives. The idea of an artificial moon does not need to be true to be powerful. It persists because it connects many loose threads into a single narrative. It gives shape to unease. It offers intention where randomness feels unsatisfying. Science continues to explore the moon with new missions, new instruments, and new models. Each discovery clarifies some mysteries and opens others. Speculation watches from the edges, asking what science does not always ask. Not how the moon exists, but why it exists in exactly this way. Between those two perspectives, the moon remains unchanged. Silent, reflective, hanging above a planet that continues to look up and wonder. And perhaps that is where the balance lies. Not in choosing one explanation over the other, but in allowing mystery and knowledge to share the same sky. Even with explanations in place, the theory refuses to fade. Decades pass. New missions return data. Models improve. And still, the idea that the moon might be something more than it appears continues to resurface, quietly but persistently. This persistence is not driven by ignorance. It is driven by pattern. Humans are drawn to unanswered questions, especially the ones that sit in plain sight. The moon is always there, unchanged, immune to weather, erosion, or decay. While everything on Earth ages, the moon remains almost exactly as it was billions of years ago. That contrast matters. Most mysteries are hidden. The moon is visible to everyone, night after night, constant, silent, unresponsive. It offers no explanation, no variation, no confirmation, only presence. Theories like the artificial moon endure because they fill that silence with meaning. They do not require proof to survive. They require relevance. And the moon touches too many aspects of human life to ever feel irrelevant. It governs tides. It stabilizes climate. It marks time. It influences sleep and emotion. Few natural objects exert such wide control without interaction. As technology advances, these theories adapt. Where earlier generations spoke of gods and spirits, modern culture speaks of megastructures and advanced intelligence. The language changes, but the instinct remains the same. To explain influence. The internet amplifies this instinct. Images of lunar anomalies circulate without context. Quotes are repeated without source. Technical language becomes simplified, then distorted. Each retelling strips away uncertainty and replaces it with confidence. But the core question survives all exaggeration. Why does the moon feel different? Even among skeptics, there is an admission that the Earth-Moon system is unusual, rare, balanced in a way that supports life remarkably well. To accept this as coincidence requires comfort with improbability. Some have that comfort. Others do not. For them, the artificial moon theory offers something subtle. Not fear, not control, but intention. The idea that existence may not be accidental. That systems may be designed rather than stumbled into. This idea does not demand belief. It invites reflection. What if the moon was placed here not to watch, but to stabilize? Not to observe, but to support? Not to influence thought, but to preserve conditions where thought could arise at all? In that framing, the moon is not ominous. It is protective. Whether true or not, the idea resonates because it softens uncertainty rather than amplifying it. It replaces randomness with purpose. That is why the theory never dies. Not because it is proven, but because it answers a question people rarely admit they are asking. Not what the moon is, but why it is here, exactly as it is. And as long as the moon remains unchanged, hanging quietly in the sky, that question will continue to rise with it, again and again, every time night falls. As the theory lingers, attention begins to shift inward, not toward the moon itself, but toward the way it affects the human mind. Long before science measured gravity or tidal forces, people noticed how the moon changed behavior. Nights felt different beneath its light. Sleep shifted. Emotions softened or intensified. The world seemed quieter, yet more alert. Modern research confirms parts of this. Lunar cycles subtly influence sleep patterns, especially in environments without artificial light. Some studies suggest changes in melatonin levels. Others note shifts in mood and attention. The effects are small, but persistent. What matters is not their size. It is their consistency. The moon does not need to act to influence. It simply exists, steady and unavoidable, shaping rhythms without ever announcing itself. This kind of influence feels different from force. It feels environmental, passive, almost invisible. Psychologically, humans respond strongly to objects that are constant yet unreachable. The moon cannot be touched. It cannot be avoided. It cannot be ignored. It is always present, just far enough away to feel separate from everyday life. This distance creates projection. People assign meaning to what they cannot interact with. The moon becomes a screen for fear, hope, and imagination. It reflects whatever the mind brings to it. In this sense, the artificial moon theory may say as much about human psychology as it does about astronomy. If something influences us so deeply without interaction, the mind searches for explanation. Intention feels more satisfying than accident. Design feels more comforting than randomness, especially at night. In darkness, uncertainty expands. The moon becomes the only constant reference point, a fixed presence in an otherwise shifting world. The mind naturally asks whether that presence is watching, guiding, or simply existing. These questions do not require answers to function. They exist comfortably in silence. That is why the moon works so well as a symbol. It is distant enough to remain mysterious, yet close enough to feel personal. It shapes life without revealing motive. Whether the moon is natural or artificial, its psychological role remains the same. It anchors the night. It regulates time. It offers familiarity and uncertainty. If an advanced intelligence wanted to influence a developing species gently, without interference, it would not need messages or contact. It would need environment, rhythm, stability. The moon provides all three. This idea does not insist on belief. It simply fits. And fitting is powerful. Because when something fits the way the world feels, the mind accepts it quietly, without resistance. The moon may be a rock. It may be a structure. It may be coincidence. But its effect on human awareness is undeniable. And that effect continues, unchanged, every night. Which leads to a final, quieter thought. Perhaps the most important question is not what the moon is, but what it allows us to become. That question settles slowly, without asking for an answer. What the moon allows may be more important than what it is. It creates nights that are not completely dark. It offers just enough light to soften fear without erasing mystery. It turns chaos into rhythm, randomness into pattern. Humans evolved under its presence. Long before cities, before language, before memory was written down, the moon was already there, shaping nights, guiding movement, marking time. Whether placed intentionally or formed by chance, it became part of what it means to be human. In this way, the moon functions less like an object and more like a boundary. It sits between day and night, between certainty and imagination. It does not reveal everything, but it does not hide completely either. Stories thrive in that space. The artificial moon theory may never be proven. It may never be fully dismissed. It lives in the gap between data and intuition, where facts exist, but meaning remains flexible. That is where the mind feels most alive. For some, the theory represents curiosity taken too far. For others, it represents curiosity refusing to stop. Neither is wrong. Both are expressions of the same impulse, to understand our place in a universe that rarely explains itself. The moon does not respond to these questions. It does not confirm or deny. It reflects sunlight and stays silent. In doing so, it invites projection without correction. That silence is powerful. If the moon were artificial, revealing it would change everything. History would be rewritten. Meaning would shift overnight. If it is natural, then its precision becomes a reminder of how unlikely life itself may be. Either outcome inspires awe, and awe is the point. The moon has always inspired pause. People stop to look at it, even when they are busy. Conversations slow. Thought stretches. Attention lifts upward, away from urgency. This pause may be its greatest function. In a world that moves quickly, the moon does not. It follows the same path it always has. It rises and sets without hurry. It reminds the mind that not everything changes, and not everything needs to be solved. Whether structure or stone, the moon invites reflection rather than action. It does not demand belief. It does not ask for certainty. It simply exists. And in that existence, it offers a mirror, not of the sky, but of the human need to search for meaning in what remains unexplained. As the theory fades into quiet thought, one final idea remains. Perhaps the moon's greatest design, intentional or not, is that it never gives answers. It only gives time. And time, when held gently, becomes rest. Which brings the story to its final moment, not with conclusion, but with calm. The moon remains exactly where it has always been. It does not react to theories. It does not respond to belief. It does not change its behavior based on what humans imagine about it. Night after night, it rises with the same quiet patience. It reflects sunlight without adding anything of its own. No signal, no message, just presence. And perhaps that is what makes it so powerful. If the moon were loud, it would invite answers. If it were unpredictable, it would demand attention. But it is neither. It stays distant enough to remain mysterious, and close enough to feel familiar. It offers light, but not clarity. Shape, but not explanation. Whether the moon is a natural satellite, an ancient construct, or something humanity has misunderstood entirely, it performs its role without interruption. Tides rise and fall. Seasons move forward. Life continues, shaped quietly by something that never speaks. Over time, theories come and go. New data replaces old assumptions. Ideas are built, challenged, abandoned, and rediscovered again. The moon remains untouched by all of it. That constancy is comforting. In a universe defined by motion, expansion, and decay, the moon feels stable, reliable, almost timeless. It reminds the mind that not everything needs to change to remain meaningful. Perhaps that is why these questions linger. Not because answers are hidden, but because the unknown feels safe here. The moon does not threaten. It does not intrude. It simply allows space for thought. At night, when the world grows quieter, attention naturally drifts upward. The moon becomes a soft anchor for awareness. Something to look at without expectation. Something to notice without needing to understand. And in that noticing, thoughts slow. Questions soften. The need for explanation loosens its grip. Whether the moon was placed, formed, or simply happened to be, it has already fulfilled its most important role. It has shaped nights, guided time, and given the human mind something distant enough to wonder about. It does not demand belief. It does not require answers. It simply remains. As the night continues, the moon holds its position silently, doing what it has always done. Watching tides move, watching shadows shift, watching the world rest beneath its light. And slowly, without effort, awareness follows that stillness. Breathing becomes steady. Thought drifts. Questions fade. The moon stays where it is. And everything else becomes quiet.